Sathyabama Institute of Science and Technology.
This is Senthamilarasi, Assistant Professor from CSE Department, Sathyabama Institute of Science and Technology. So today video we are going to see about conversion of context-free language to context-free grammar part 2. In the previous video we have seen about the same thing as some similar examples we have seen as a part 1. So in this we are going to see few problems like construct the CFG for the language L equal to a power 2n b power n where n greater than or equal to 0 and construct the CFG for the language L equal to a power n b power n plus 2 where n greater than or equal to 0 and then construct the CFG for the language L equal to a power n b power 3n plus 2 where n greater than or equal to 0. So in this topic we are going to see these three problems. So before going to that, we can refresh with what is meant by context-free grammar and what is meant by context-free language. As previously said in my previous video, like context-free grammar is nothing but it is a finite set of grammar rules in a quadruple, so which will be consisting of 4 tuples N, T, P, S. So N is a non-terminal, T is a terminal and P is a production rule, S is a start symbol. Then about context-free language, whatever the language is accepting our context-free grammar, that language we are calling as a context-free language. Simply we are calling that as CFL. So the first problem is construct the CFG for the language L equal to a power 2n b power n where n greater than or equal to 0. So this is a question. For this what we need to find means n greater than or equal to 0 means we need to find for n equal to 0. So n equal to 0 means if we substitute in a power 2n b power n, it will be a power 0 b power 0 which is nothing but epsilon. N equal to 1 means in the place of n I am substituting 1, it will be a power 2 b power 1 which is nothing but AAB. So n equal to 2 means a power 2 into 2 which is a power 4 and b power 2 which is nothing but 4a's and 2b. So next n equal to 3 which is nothing but a power 2 into 3 which is nothing but a power 6 and b power 3 which is nothing but 6a's and 3b's. So like this we can do for many number of n's. So now which means for 1b I am getting double the number of a. So double number of A's for number of B's and another thing A is followed by B. So according to that I am going to construct the production rule first. So how I will be constructing the production rule means normally for A power n, B power n greater than or equal to 0 will be A implies A capital A B. But here they have given in the multiples a power 2n. So which means we having additionally 2a's in the beginning. So if it is in the multiplies means we need to add that many number of a's in the beginning of the production rule itself. So normally a implies AAB for a power n, b power n. So here it is a power 2n, meaning is what we need to add 2a in the beginning, then the production rule will become a implies AA capital A B. So here as n equal to 0 epsilon is there, we are just putting a implies epsilon. So we having two rule, one is a implies AAAB and a implies epsilon. This is a production rule. Based on this production rule I need to derive the grammar. What is my grammar? NTPS. So n is nothing but the capital letters. What are the production in the production rule? What are the letters is there in capital letter? I need to write over here. So capital A. So that is my one non-terminal. So what are the small letters I am having? A, B and then epsilon also will be considered as a terminal. So for T, A, B, epsilon. So and S is nothing but the starting symbol. So here from where we are starting, from A we are starting. So S equal to A. So now we are representing NTPS. We are substituting all these NTPS in this G. G is nothing but what? Context free grammar. So A, B, epsilon, B where I have given this production rule. A is nothing but the start symbol. So here we have given, so whether it is right or wrong we can check using one string. So here we have taken one string, so where we are just deriving from the start symbol. So what is the start symbol? A. So what is given here? AB. So I have written that is rule 1. So then capital A I am substituting again with small 2a capital A, B. So again I am substituting the rule 1. Okay, in the place of capital A, I am substituting the rule 1. So next here, instead of A, I am substituting with what? Epsilon. So if I am substituting epsilon, I am just getting the string. How many A's are there? I am having 6 A's and 3 B's. Meaning is what? Double the number of B's I am having for A. So this is about this first question. Next we will move on to the next question. So my second question is, construct the CFG for the language L equal to A power n B power n plus 2 where n greater than equal to 0. In the previous question we saw the multiplies of A's. So in this question we are seeing the addition of B's. So here how we can construct? Again the same thing, we are substituting for n equal to 0. It will be A power 0, B power 2, it will be nothing but double B. Then n equal to 1 means in the place of n I am substituting 1, it will be A power n, B power 1 plus 2 which is nothing but B power 3. So A power 1, B power 3 I am writing as A 3B's. And again n equal to 2 I am writing as A power 2, B power n plus 2. So 2 plus 2 it will become B power 4, it will be 2A's 4B's. Again n equal to 3, it is A power 3, B power 3 plus 2, it is A power 3, B power 5. So it will be 3A's 5B's. So like this we can derive for many number of n's. So here what it is, A is followed by B, that is the order. We should not follow B followed by A, as in the question A is followed by B, that order we need to maintain. So based on this, I am going to derive with the production rule. So normally for A power n, B power n, the production rule will be A implies A, B. But here they have given with A power n, B power n plus 2. Additionally, 2 B's are added. If so, in part of addition they are giving means I need to add that many number of B's at the termination part. So here I am adding with what? Instead of epsilon, I am just substituting with what means BB. So A implies AAB, A implies BB. So what you need to understand means multiplies means I need to add that many number of A's in the beginning of the production rule. If it is in part of addition means I need to add that many number of B's in the termination part. So based on this again I am writing with the NTPS, which is nothing but the context free grammar. So what is my N? So here I am having the capital A, so that is my non-terminal. So T, what are the terminal? A, B, and here epsilon will not be there, A, B, okay. And here the start symbol will be what na? A, so A. So I am just writing in the NTPS. So now I need to write the grammar. So G equal to the non-terminal A and terminal AB alone, the production rule already given, and start symbol is A. So again for this I need to derive with the string. So how many, here we are taking 3 A's and 5 B's. For this I am just deriving where I am applying with the rule 1. What is my rule 1? A implies AAB, so I am just substituting over there. Instead of capital A, again I am just substituting with the rule 1. So again I am substituting with the rule 1. So finally for capital A, I am just substituting with 2B. So I am getting 3 A's and 5 B's, which is the string what I need. So this is how you need to do the you need to convert the context free grammar for this particular language. So we will see the next problem. So our next problem is in the combination of addition as well as in multiplies. I have taken this problem. So where I am going to construct the CFG for the language L equal to A power n, B power 3n plus 2 where n greater than equal to 0. So again I need to substitute n equal to 0, which will be A power 0, B power 0 plus 2, which is double B, and n equal to 1 means A power n, B power 3 plus 2. How 3? 3 into 1, so 3 plus 2, it will be A power 1, B power 5, so 1A and 5 B's. Again n equal to 2 means A power 2, B power 3 into 2 will be 6, 6 plus 2 will be 8, so 2 A's and 8 B's. N equal to 3, A power 3, B power 9 plus 2. How 9? 3 into 3 is 9, so 9 plus 2, so it will be A power 3, B power 11, which means 3 A's followed by 11 B's. So here also the order we are maintaining, A is followed by B. So again for this I need to write with the production rule. So what is my production rule? A power n, B power n. The production rule will be A, capital A, B. So here if it is multiplies means what I said before the production rule, I need to put that many number of A's. If it is in case of addition, I need to add that many number of B's in the termination part. So here I am having in the b power 3n, where 3 is in the part of multiplies. So multiplies means how many multiplies in the case of here means b 3 power n plus 2. So here termination la I am having 2 over here. So in the termination I am just including 2 b's. But here b power 3n multiplies. So we are adding the 3 b's in the front part. So if it is in the case of addition, I am just adding in the termination. If it is case of multiplies, I am adding in the front. So my final production will be A implies AA, BBB, and then A implies BB. So this is the production rule. According to that, again I am framing with the NTPS. So my N is nothing but my capital A, my terminal will be AB, and production rule this one, and capital A will be my start symbol. So again I am just deriving the string, where I am giving the string like AA and 5 B's. For this I am just deriving using this production rule. Whether it is right or wrong, I am just checking over here. So I am taking with the first rule, and then instead of capital A, I am substituting with the 2 B's, where the string is actually present in this part of string. So we can say this production rule is right. So like this only we need to frame, or we need to convert our context-free language to context-free grammar. Thank you for watching this video.